heap tree. Now we use array to construct heap tree. There are two type of heap tree, say min heap and max heap. In max heap, the root root data should be more than left data and right data. Okay, so if it is max heap, now in min heap, root data should be less than left data and right data. Okay, now first of all we should know what is nearly complete binary tree. Suppose the tree is like that. Now it is complete binary tree. Now if you delete 9, if you delete G, then it is nearly complete binary tree. It is left fill, okay, filling from the left. Now if you delete E, then it is not nearly complete binary tree because it is not fill, left fill. If you delete F, then it is nearly complete binary tree. Obviously you can delete T. If you delete T, then it is complete binary tree. Similarly, if you delete B, then it is not nearly complete binary tree, but if you delete C, then it is nearly complete binary tree. Okay, so heap tree, all heap trees are nearly complete binary tree or nearly complete binary tree. So if it is not nearly complete or complete binary tree, then it is not a heap tree. Okay, now we can see just one example of heap tree. You can see here 90 is 90 is a root. The content of the root is more than 62 and 71. Okay, so 90 is more than 72 and 71. 62 is more than 45 and 63. Okay, 45 is more than 22 and 33. 71 is greater than 22, 20 and 40. So this is what max if. Now in min if, the 3 value is lesser than 8 and 11. 8 value is lesser than 9 and 10. 11 value is smaller than 23 and 40, and so on. So this is the example of max if. This is the example of min if. Now we will see the application of heap tree one by one. How to construct, how to delete node, how to insert node, how to apply heap sort algorithm, and so on. Now you can see the algorithm for that is a heap tree. Okay, so here you're using max if. Now it's the parent part. Okay, leaf part, the right child, it will return the address of the right child. Build max-heapify. Okay, next build max-heap. It's a heap sort. This is for heap sort to display the content of the heap. Okay, now heap maximum, display the content of the maximum node, maximum value. This is what heap extract. Clear? Now heap increase key, this is the heap increase key, and this one is the max heap insert. You want to insert a data into the heap tree. And main function, inside main function, these are the options: 1 to create heap, 2 to display maximum, 3 to sort, 4 to display, 5 to rebuild the max heap, 6 to insert data into the max heap, 7 extract maximum value, 0 to exit. So enter the option. If you case 1, call the function build max heap. Case 2, call the heap maximum may. Case 3, call the heap sort. Case 4, call display content of the heap. Case 5, called build max heap. Okay. Case 6, max heap insert a data into the heap, and heap extract. Okay, so delete root node, delete maximum from the heap, and case 0 to exit from the Now suppose one max heap is there and array say A, that means starting from 1 2 3 4 5 6 7, so 90, then 62 71 45 and 63. Parent function parent I return floor I by 2. Okay, now if it is say 62, so the parent of 62, so we are passing the index array index 2. So if you passing array index 2, then return 2 by 2, so 2 by 2 is what, 1. So the parent of 62 is 90. Okay, this particular node. Now who is the parent of 63? Sorry, who is the parent of just it is assume 33. Okay, okay, 90 62 60. So now put 60 here, 51. Now if it is say 33, okay, then who is the parent of 33? The index of 33 is what, 5. So it will return parent of index I index is what, 5. So 5 return 5 by 2. So 5 by 2 means what, 5 by 2, and we are passing the floor value. Okay, so 2.5, so it will return 2. So 2 is what, 62. So the 33, the parent of 33 is what, 62. So in this way we can identify who is the parent. Now who is the left child? So the 91, the index of the 90 is 1. Who is the left child? 2 into 1, that is 2. So 62 will be the left child. Now who is the left child of 62? So the index of 62 is what, 2. So it will return 2 into 2, 4. So 4 is this one. So the 45 is the left child of 62. 45 is the left child of 62. Okay. And we may do one thing, initialization. Initialized any the array using some unusual value, say minus 99 99. Okay, if you want. Now who is the right child? Who is the right child of that? So the right child will return 2I plus 1. So 91, who is the right child? So 2 into 1, I is equal to 1. I 1 is the index. 2 into 1 1, 2 into 1 2, plus 1 3. So the 71 is the right child of 90. Who is the right child of 62? The index of 62 is what, 2. So 2 into 2 4 plus 1 5. So 33 is the right child of 62. So in this way we can identify who is the right child, who is the left child. Next, the next function is max-heapify. Okay, now suppose you have modified the content of this particular, suppose index is 1 2 3 4 5 array index. Now suppose you want to modify the content. Now suppose instead of 62, now it is 6. You have modified it. Now what to do? How to max-heapify? How to convert this tree into max-heap? Okay, now you have to apply this particular function for that. Now L is equal to left of I. So what is I here? I is a 2. So here I is equal to 2. L is equal to left of I. So L is equal to, what is left of I function? So left of I is 2 into 1. So 2 into I. So here I is equal to 2. So L is equal to 4. And what is the R value? R is equal to 2 into 1, 2 into 2 plus 1. 4 plus 1, it is 5. Now what is n? N is the heap size. 1 2 3 4 5. N here, sorry, n is equal to 5. Okay, the heap size 1 2 3 4 5. Now L is less than n. So what is L? L is what, 4, and less than n. Yes, condition is true. A1 is greater than AI. So what is, sorry, AL is greater than AI. What is AL? A4. A4 is what, 45 is greater than AI. What is I? I is equal to what, 2. The condition is true. So largest is equal to L. So L is equal to 4. So largest is equal to another variable. Largest is equal to 4. Okay. Now R is less than N. What is R? R is 5. Less than equal to N. 5 is what? The condition is true. AR is greater than A largest. What is AR? AR is 5. So A5 is greater than A largest. A5 is more than the condition is false. So don't do anything. If largest not equal to I, what is largest? Largest equal to 4. What is I? What is I? I is equal to 2. This is I. The condition is true. Then using this particular line, swapping data in between I and largest. So I is equal to 2 and largest is equal to 4. That means swapping in between these two nodes. So after that, this will be the 45 and this will be the 6. Max-heapify A largest. So recursively we have to check. Okay. So now the largest is what? Largest is what? 4. That means apply this particular, pass this particular array index to check further. Okay. Now we can check quickly. Max-heapify, calling the same function. L is equal to left of I. What is L? Left of I is equal to what? Largest. I is equal to, now I is equal to 4 because we are passing the largest. Largest is equal to 4, so I is equal to 4. So L is equal to, so L will be the 8. L will be the 8 and R will be the 9. L is less than equal to N. The condition is false because L is 8 and N is 5. Condition is false. Don't do anything. And so largest equal to I. So what is largest? Largest equal to I. I is what? The value we are passing 4. Okay. Now R less than equal to N. What is R? R is equal to say 9. Condition is false, so don't enter into this particular function. Don't modify the content of the largest. If largest not equal to I, largest not equal to I. So in this case, I is equal to 4, largest is equal to 4. The condition is false. The condition is false means what? Don't enter into the if statement and don't call the function once again and come out from the loop. Okay. That means if the tree is like that, okay, so that means if the tree is like that, now suppose 90, 62, 71, okay, 45, 60, 22, 33, okay, and say 20 and 42. Then if you want to, now it is not 62, now it is, if it is 2 6, okay, that means it is not a heap tree because it is not a max heap because the maximum root value should be more than the both the children. So what you can apply, we can call this particular function where a is the array, okay, and I is the index. So here 1 2 3 4 5 6 7 8 9. So we have to apply the array, we have to pass the array, okay, where the content of the tree is there and the index. The index will be the 6. Now compare these two. So 60 is more than 60 is more than all these two. So replace 6 with 60, okay, and now it is 6. Okay, now suppose you want to now it is instead of 9 it is say 90, you have modified it to 9, so it is not a max heap. So compare 60 and 71. So 71 is more than 9, so replace 9 with 71 and it is 9. Once again recursively call the same function, compare these two. So this one is the bigger than, it is 42 and it is 9. Okay, so that is what max-heapify function. there, you have to convert this into max heap. Okay. Okay, so build max heap. A is the array. We are passing the array A. For I is equal to 4 n by 2 to 1. So what is n? N is the array size. So array size is what? N is equal to 8, the heap size. So I is equal to 8 by 2, 4 to 1. Okay. So I is equal to, first time it is 4, then 3, then 2, then 1. Now if it is 4, that means we have to start process from here. That means we will not process the nodes if these are the leaf node. So first internal node is what? 13. So we have to start process from this particular node. Now apply max-heapify. So already you know the max-heapify. How to apply max-heapify? We have seen this one. Okay, we have seen this one. Now already this particular portion already it is a max heap. Okay. Now I is equal to 3. So if I is equal to 3, now if you compare these two, 70 is bigger than the 63. So now it is 7 and it is 70, now it is 7. So swap these two values. Next it is 2. Now for this particular, which one is the bigger? 13 and 40. 40 is the bigger. So replace 9 with 40. So now it is 40 and it is 9. Now for the 1, compare these two, 40 and 70. So 70 is more than 33. So here put 70 here and 33. And in max-heapify, recursively you can call another max-heapify. So 33, you have to compare these two. So 63 is bigger than 33. Now it is 63 and 33. Now after that, the tree will be 70 will be the root maximum, left child 40, right child 63, okay, left child 13, right child of 40, it will be the 9, left child of 13 will be the 4, left child of the 63 will be the 7, and right child of the 63 will be the 33. So in this way we convert this general tree to heap tree using array. Okay. Next we can see the heap sort algorithm. Now in this heap sort algorithm we can see here, so 70, 40, 63, 13, 9, 7, 33 and 4. So for I is equal to n to 2. What is n? N is equal to 1, 2, 3, 4, 5, 6, 7, 8. So 8 to 2. So if n is equal to 8, okay, then swap first value with the 8 value. So a1. So for swap, so first value is what? 70, and so now it is 4 and it is 70. Okay, this 3. Swap a1 with ai. Now print 70, decrement n value. Okay, so max-heapify, call the max-heapify function, call this particular function for this particular data 4. So here n minus 1, so reduce the heap size. Now instead of n is equal to 8, now it is 7. That means now this 70 is not part of the heap. Okay. Now apply max-heapify. So compare these two. So it will be the 63. It will be 4. Then compare these two. This will be the 33, and this will be the 4. So after this operation, the heap will be 63, 40. Okay. 33, 13, 9, 7, 4 and 70, but it is not part of the heap now. Okay. Now once again, now if n is equal to, now if it is 7, now 7 means what? 1, 2, 3, 4, 5, 6, 7. Swap a1 with a7. So 63, swap with this one. So 4 is, it is 4, so swap this 4 and 63. Now then print, so we have printed 70, now 63. Decrement the in value, max-heapify the in. That means what? Once again we have to apply max-heap, we have to convert this tree into max-heap, okay? And now 63, the heap size is 7, so 1, 2, 3, 4, 5, 6. Sorry, now initially it was 8, then 7, now so it is 6. So 1, 2, 3, 4, 5, 6. Now this 63 is not part of the heap, okay? And apply heapify algorithm, then max-heapify algorithm. Now compare these two, so it will be the 4 and it will be the 40. Compare these two, this will be the 13 and 4. So if it is the case, then the tree will be 40, 13, 33, okay, 4, 9, 7, 63. Now this 63 and obviously 70 is there. This 63 and 70 not part of the heap. Okay, so once again we can compare the last value is what? 7. Swap 40 with 7. Now if you swap this one, if you swap this one, then this will be the 7, 13, 33, 4, 9 and 40. Now this 40 decrement the in value, so heap size, so now 40 is not part of the tree, okay? And apply max-heapify, so compare these two, so this will be the 33 and this will be the 7. So after this the tree will be 33, 13, 7, 4 and 9. So this is max-heap. The remaining value are 40, 63 and 70. Now the last value is what? 9. Swap this one, so this will be the 9 and this will be the 33. Reduce heap size. Now reduce heap size is what? Now 33 is not part of the heap. Now after that the situation is like that: 9, 13, 7, 4, 33, 40, 63, 70. Now all the values are in array but not part of the heap. Okay, now apply max-heapify. So this will be the 9, this will be the 13. Okay, so after this the max-heap is 13, 9, 7, 4. Max-heap, then content of the array 30, 40, 63 and 70. Now swap, the last value is what? 4. Swap these two. So if you swap these two, the tree will be like that. Say now it is 4 and it is 13. Reduce the heap size. So 4, 9, 7, 13. We have reduced the heap size, so 13 is not part of the heap now. Okay. 33, 40, 63 and 70. Okay, now once again max-heapify this particular part, compare these two. So this will be the 9, this will be the 4. That means the heap tree will be the 9, 4 and 7. Now 13, 33, 45, 40, 63, 70. They are in array but they are not part of the heap. Now the actual heap is what? 947. Now swap the with last one. So now it is 7 and it is 9. Reduce the heap size. Now if you reduce the heap size, the situation is like that. 9, now 9 is a part of the array but not part of the max heap. 13, 33, 40, 60 and 70. Then finally, so because the I will vary from n to 2, so okay, so the second one, so swap with this, so this will be the 7, this will be the 4 and reduce the heap size. So after reducing the heap size, this will be the 4, 7, 9, 13, 33, 40, 63 and 70. Now you can see here the content of the array. Now 4, 7, 9,